Hi, welcome to Draw Plans. I'm Tom Norris, and today we're going to take a look at wall thicknesses and how we represent them in our drawings. Sometimes the difference between success and failure is just 20 mil or 30 mil, as in squeezing in a bathroom or getting a corridor, or in tight spaces, especially if you're doing subdivision or conversion work. It's really important that you have a good grip of wall thicknesses, and that is not just the outside but the inside as well. So today's tutorial is based around trying to give you a reasonable guide as to where you should be aiming for with regard to the thicknesses. And obviously if you're a seasoned veteran and you know this, then that's fine, but this is for the UK property market, so the sizes are all metric. And so we're going to start with today as in new build house today, or adding on an extension to a house today. What we're looking at, this is on a brick facing extension. You're looking at a modern brick. A modern brick is metric, and it's 215 by 102.5. These are the numbers you need to be concerned with. So you've got the brick on the outside, you got 100 mil allowance for cavity, as in insulation, etc. You've got a reasonably standard concrete or breeze block inside. And then of course you're going to dry line or plaster internally, and for that the combined allowance is 323. So your wall thickness represented on a drawing, if you're adding on an extension, your exterior walls you should be aiming for 323. If it makes it easy, round it off to 325. That's what we do quite a bit of, so that there's a little bit of tolerance there, and always in favor of having it a little bit bigger, a little bit thicker, rather than the other way around, where you could be really cut for sizing inside. So yeah, represent that 323 and you'll be doing fine. So on the same external wall where it's they've gone for block inside skin and outside skin, then we would need to be a little bit thicker, because again we're putting dry lining or plastering inside, but we also have rendering on the exterior, which we allow a little margin, another 20 mil for. So combined here, so the block wall is a little bit thicker, so 340, that's where you should be aiming for. And again, that's a modern block wall for a house or an extension in the UK in metric. Incidentally, I didn't say, just in case, I'm using TurboCAD Deluxe 2022. Pretty stable product, ideal for especially for young technicians and builders and people who are interested in architectural design. It's a great gateway product because it only costs a few $100s, and you don't have to do a subscription where you're paying out thousands per year. So I'm not affiliated with TurboCAD. I'm just telling you for your own sake, it's a great old product. It's pretty stable and it's ideal. We give it to all our technicians because it's not too intimidating. Anyway, getting back, brick wall, 1950s to the 70s. So again, when you go to do work on any kind of property, it's important you have a good look at the actual property and when it was built and so on, because that's going to reveal or tell you, if you have the experience, it's going to tell you roughly what how the house is made, whether it's likely to have wooden floors, concrete floors, whether it's likely to have insulation, what the walls are constructed of, and so on. So it's important you start to learn that as you move along with your career or your chosen career path. So brick walls, 1950s, 1970s house. Generally there was a little bit of cavity, so about 60 mil cavity, not always filled, unfortunately, but the brick sizing was more or less the same, and it would have been brick on the inside as well. So what you're looking at is a combined with a bit of rendering on or plastering on the inside, brick inner, brick outer, a little bit of cavity. You're looking at about 280 for a 1950s, 1970s house. So if we go back a little further, 1930s, 1960s, no cavity at all. So we're looking at brick out or brick in. Oddly enough, even though some of the bricks would have been, metric bricks came in the 70s, and so we had imperial prior to that. I think the 70s, that was the joining the EU. All the imperial measurements went out the window and we started going metric. So metric bricks came in around the 70s, early 70s. But before that, imperial bricks. But they were roughly the same, 1 or 2.5 or 1 or 2.6 equates to. They basically did a conversion. They didn't change the size of the brick. They just went from the measurement, to the imperial measurement, to the metric size without creating a new brick. Anyway, 1930s, 1960s, we're looking at no cavity wall, around 235 all in. So again, if you're looking at a nice 1930 style house, 1940s, you have an idea that the exterior walls should be 235. Right, let's go back a little bit and we start going into the Victorian era, Edwardian and so on. Now, this is a little bit more interesting, but the bricks are more or less the same. We've done the sizing on the old stock bricks because some people prefer the metric or the imperial, so the sizing is the same on the two of them. But we're a little bit thicker. 228 is a little bit longer and 114 is the width here. And then of course that's the height, so they were lower than the modern brick. Anyway, combined on an old Victorian house, exterior wall, bit of rendering, you're looking at a little bit of plastering rendering here, you're looking at about 258. Now what's interesting is, and I used to get caught like this all the time when I was younger, I'd go to do a measured survey, and when I measured up inside, I couldn't get the numbers to work because what I didn't realize was that on a 3-story house, the Victorian build generally had 3 bricks on the ground floor, and then as you went up a floor it narrowed down to 2 bricks. And so what that means is that the rooms on the ground floor were smaller than the rooms on the upper floors. They were a brick smaller all the way around, so effectively 2 bricks smaller. And it's hard to get your head around that. You think, oh, I've made a mistake on the numbers, I got this wrong, so do I go with the top, do I go with the ground? Anyway, when you find yourself in this situation, just consider that, was it a 2-story, 3-story or 4-story, because the wall thicknesses. In fact, if it had a basement when you go down, it could well be 4 brick thickness. So you have to check that out and look at the building, not just throw walls up. So on a 2-story house, the average Victorian build would have been around 258, 260 mil. Plaster varied considerably depending on how good the bricklayer was. You could even find 40 mil of plaster, so it could be 280 all in, but we're giving you a guide here. It's up to you how do you interpret. So the 3 bricks if you're going on 3 floors. If it has a basement, consider adding another 4th floor, because in other words the rooms get smaller as you go down because the walls get thicker. So it's not rocket science, but there you go. Imperial sizes, metric sizes. So what we've done now is we've had a little look from the modern build back to the Victorian. So keeping an eye on these numbers and how they are and what they represent should help you to do more accurate drawings if you're not clued up as to what the sizes were before. So hopefully that helps you. So here I threw a few pictures in and a few diagrams. So that's a modern build. Brick outer skin, Celotex are the equivalent in the middle, cavity about 100, and then another block or a brick inside. So there you go, that's your 300, and then it's going to get a bit of plastering or boarding or dry lining, and there you go, you're about 320, 330, and it's for this one. So just a slightly older version where we didn't use the Celotex, we used the rock wool. That's your brick again, standard brick 102, 100 mil of rock wool, standard block 100 mil. And again, if you go on the internet, you're going to find loads of these little diagrams, which are useful to have, and have them somewhere where you can basically access them. So if you do forget what the numbers are, even maybe possibly just do a little screen save on these and keep it in your file notes, so that when you're doing building for a while, just you can bring a photo of this. In fact, I'll show you how to do it while I'm here. So I'm going to do a snip and snatch. There you go. So I've got that. I'm going to save it in downloads, screenshot, and that's good enough. And now I'm going to incorporate it into my drawing. So if I insert a picture from file, screenshot, wall thickness, and there you go. And if you don't want the line around it, just so basically if you bring that into your drawings, you've got it there in front of you. Maybe you want to do it at a better resolution than what I've just done, but yeah, but that's the idea behind it. So yeah, bring it in and get on with it. Right, interior walls. Interior walls is another contentious issue. Now these are really important when we're doing the conversions, because wall thicknesses, as I say, you're struggling sometimes to fit a bathroom in, or a shower. The thickness of the wall, if you're really cut for space, you're thinking, okay, can I get away with a stud wall? Maybe instead of 100 mil stud, maybe I can get away with 75. So you play with the numbers just to slim down the walls a bit. So, but what I'm going to give you here is kind of standard sizing. So if you're on the ground floor and you're using a block, so you've got an allowance here of 100, and then plasterboard, dry line. But again, you see, if the bricklayer is rubbish and the walls aren't straight, then this can in fact the dry lining can in fact become 50 mil rather than we've allowed for plasterboard, which is 12.5 and a little bit of skim on the top, but in fact it could end up being 30 mil. But 130 is a fair representation for an internal block wall with a little bit of boarding on either side. That's been done reasonably, in good quality or decent standard. So when it comes to the stud wall, again you've got 100 by 50, and again depending on where you buy the timber, it could be 96 by 47, but again we allow 100, we allow plasterboard on either sides, bit of insulation, not a bit, but a good solid insulation between the studs, and you end up with 130. So allow 130 as a standard internal stud wall. And by the way, and this comes up a lot for us when we're doing conversions, because part of the fireproofing means you have to build up the 30-minute fire protection on walls surrounding stairs, landings, anywhere where lots of people moving around. So you've basically got to beef up the board 2 layers of the pink. So you end up with 145. So we tend to allow 150 here for these particular walls in the hallway. And again, I'd rather the walls were represented slightly thicker than the other way around, because the other way around, if the builder is trying to fit a door and he just can't get it in because he's cut by 10 or 15 mil, you're starting to cut down fireproof doors and so on. So that's not good. So it's better to be oversized with the walls than under. It's a good lesson. Then I also thought let's mention the old Latin plaster wall, which is on the Victorian houses. Ones that are really messy and dusty to remove. So there you go. On those now, 100 mil inside is about right, as in the stud. And then the lats and the plaster, well, we find the Latin plaster is definitely thicker, so we allowed 30 mil on both sides. So on old partition wall in a Victorian house, we would allow 160 rather than say on a new one, which is be 130. So new stud wall 130, old Latin plaster wall 160. So if I was you, I'd pay particular attention, because the idea is to be able to represent as accurately as possible, and so you start to learn the makeup of the walls for the different types of houses and what the sizing are and how they fluctuate depending on the quality of the build, etc. Okay, that's about it really for this one. It's a shortish tutorial, but hopefully it'll help you to make or create more accurate drawings as you move forward. So don't forget, I'm still looking for subscribers, and even if you hate me, at least hit the like button, because you probably got some value out of this. Okay, thanks a bunch for watching. See you in the next video.